Hey everyone, welcome to LogRocket. Sorry, PodRocket. No, well, actually, so actually today it is both LogRocket and PodRocket because I have a very, very special guest, Pascal Kriete, who is the VP of Engineering here at LogRocket and also was employee number one at LogRocket. So he's been a member of our team basically forever. And I'm super excited to have him on the podcast today.
Yeah, thank you, Ben. It's good to be here. Doing well.
So yeah, I guess I had a Freudian slip in my intro because we are on PodRocket, but today we're going to be talking about LogRocket, and I think there's a lot of things we could talk about. I think what may be potentially interesting to our audience to start with first is like an overview of how our systems all work. Um, you know, we're I think folks probably know the product, and maybe we could just start with like a 30-second intro about the product itself. I don't want this to turn into an advertisement for the product, but it's helpful just to give some context, like what LogRocket does, and then we can kind of dive into how the system is architected and all that fun stuff.
Yeah, absolutely. I think probably the most interesting thing to talk about when it comes to how LogRocket works is talking about the data that we have. And essentially, what we record is everything that happens on the screen. So in LogRocket, you can get a video of everything the user has done alongside everything you would see in your Chrome developer console. So network, logs, exceptions, performance, all of it. And the general idea behind LogRocket, and now it is turning into an ad, sorry, is that you can record what your users do, and then you can figure out what they've done after the fact. So if you have a user that went through, I don't know, a checkout flow, they clicked on a button, the button didn't work, you can then go into LogRocket, you can see them go through that checkout flow, you can see them click the button, and you can then see, okay, a network request went out, it flaked out at our CDN, an exception got thrown, the button didn't work. And now I have something I can try to reproduce and try to fix instead of just getting, hey, this doesn't work, and some poor engineer needs to go figure out how to reproduce.
And I think the kind of the obvious first thing to talk about there is the video. So what is the video? Or I can say this is session replay. It's a technology that has been around for a fairly long time. Certainly predates LogRocket itself, though. I think some of the things that we do around session replay, or many of the things, are unique, and our implementation of session replay is pretty unique. So maybe you could explain to us like what session replay is, how it works, and we can go from there.
Yeah, I think the biggest thing to highlight there is it's not video. And that surprises a lot of people. It does look exactly like a video, but what we're recording is the DOM. And so the DOM over time, we'll take a snapshot of the HTML when the page loads, we'll record diffs over time, record mouse positions, scroll positions, inputs, and you can put that all back together to look like a video, but it's not.
Got it. And so when you say putting it back together, could you talk more about like how that replay works, and maybe even before that, like how do you capture diffs to the DOM? How do you know when the DOM changes? Like how does that work from a JavaScript perspective?
Yeah, so the first thing we capture is just a snapshot of the DOM, and that you can get by walking the DOM as it stands. And then right around, I think, IE6, IE7, browsers added this API called Mutation Observer. And what that does is you can observe any DOM element and all of its children, and it'll tell you when something changes. It's a pretty verbose API. It'll tell you parameter A changed, parameter B changed, node got added, node got removed, and you pretty much get every change on the DOM. And so you can kind of treat it like Git, where you have an initial state up front and then diffs over time. What we do at Replay is we take that initial DOM snapshot, we put it in an iframe, and then we apply those diffs over time so that the browser is actually doing the re-rendering for the video. And the only thing that we really render ourselves is the mouse, which is, surprise, an image of a mouse. And so we'll put that image of a mouse over the video, we'll fix scroll positions, we'll fix inputs, and it ends up looking exactly like a video with all of the browser rendering applied.
And what about like style sheets or images, like things that could change between the time a session is originally recorded and then when you subsequently replay the session?
Yeah, good question. We essentially just cache them. So we will download your images, your CSS, cache them ourselves, rewrite your DOM a little bit to point at those cached assets, and then use those. It also means that you don't actually have to upload all of your images from the browser. That would be a little too much bandwidth usage for us. So when we see an image tag, we'll go grab the source, we'll download it, we'll cache it, and then reuse it at playback time so they don't change.
Got it. And yeah, performance is an interesting question. So I know there's quite a lot we do with regards to performance and ensuring that our recording doesn't slow down someone's web application. So to the extent you're comfortable sharing, like what are maybe some of the more interesting things we do to preserve performance?
Yeah, I think most of the audience is probably aware of web workers, and that's probably the biggest piece we do is we try to do as much work as possible in a worker. You can't do all of it in a worker. All of the capture still has to happen in the main thread. But most of our performance optimizations are around how do we not block the main thread. And so we have a little control loop that runs that looks at how much time are we taking up, how much CPU, memory, network, and we actually end up adjusting how much we record and what fidelity we record at based on how much time we're taking up. At the end of the day, if there's no network or we're blocking the CPU or something like that, we will actually just turn off. We're not more important than your app, as much as I would like that to be true.
And when you say fidelity, so like, if you were just capturing a video, then you could just record it at lower resolution or fidelity. But when you're capturing DOM elements, where is the degree of like variability and fidelity, or like what can you stop recording but still add value if you have to slow down your recording due to performance?
When you're capturing video, one of the things you can slow down is frame rate. And so we actually end up diffing less frequently as things get busier. So by default, we might say every 200 milliseconds we take a diff. If the network is really bad, maybe we'll go to 500 milliseconds or every second. And every second is still enough that if the user clicks on something and it changes, it's a pretty instantaneous experience at playback. We can also drop things like large logs, large network. Performance data ultimately doesn't change that much if you currently have 100 megabytes of memory usage, and then 10 seconds later it's 120. You can kind of guess roughly what happened in the meantime. So we can slow some of those streams down as well.
Correct me if I'm wrong, but with the DOM, we're not taking a snapshot every X number of seconds. Like the mutation observer is telling us when things have changed. So what exactly do you mean by like slowing down your frame rate or sampling rate to every n seconds?
Correct. So we actually record all of the mutations that happen, but we more or less just mark elements as dirty. So we can say this element was mutated in some way, and then every second or so go through all of the elements that have been mutated and find the minimal set of mutations. So if you imagine that you add a class and then you immediately remove that class again, if it happens within 10 milliseconds, we shouldn't have to record that. And so we'll look at what has changed over the last 200 milliseconds and remove anything that's duplicate or has been undone again to create kind of our final diff.
That makes sense. And I'm curious, LogRocket recently launched a mobile version of Session Replay for iOS and Android. I myself am significantly less familiar with mobile development than I am with web development. So maybe we could start with iOS or Android or both, like whatever you think is easiest to kind of comprehend. Curious to understand like how Session Replay on mobile works, how mobile applications are structured, and yeah, we can go from there.
Yeah, when you say you didn't know how mobile works, neither did we. We're a team of web developers, so it was a learning experience. At the end of the day, mobile is sort of traditional graphics processing. You have draw operations that happen to some sort of canvas or frame buffer, and then the screen shows the composite of those draw operations. So what we can do, and let's take Android because it's open source and you can actually go look at the underlying code here. We can capture the draw operations that happen. And then at that point, it's very much like a DOM. You have a tree of operations in different parts of the window, and you can record those, you can upload those, and then you can play them back on a web canvas.
Got it. So it's kind of like for web developers, we're used to the HTML canvas. You say draw a line, draw a rectangle, draw text, and LogRocket on Android is just listening to those. So we have some way of like polyfilling or listening on those draw operations every time it happens. We record that. I'm curious, like from a performance perspective, intuitively it would seem like there's like orders of magnitude more draw operations in like a mobile app than there would be changes to DOM in a equivalent web app. But is that true or not? And if so, how do we think about that?
Yeah, same problem as web in many ways. So we have a DOM, we have way too many mutations coming out of Mutation Observer, and every few hundred milliseconds we decide, okay, now is a good time to capture. You can do the same on mobile. One of the things you can do on Android is you can tell a view to draw itself. And so you can on demand get all of the draw operations that that view has most recently performed, and you can record those separately. And so now you get into sort of optimizations that I don't want to get too deeply into around when do you ask a view to redraw itself, where do you capture those operations, and then how do you play them back?
Got it. But okay, so essentially every time we want to take a screenshot, so to speak, instead of like taking a screenshot and having like, lots of pixels that we have to capture, we just ask, hey, view, how would you draw yourself if you had to redraw yourself right now? Which is a lot less data than an actual screenshot. And then we keep track of that draw operation. And when we do the replay, how does that work?
Yeah, that's an interesting question, an interesting problem. So at the lowest level, it's a very similar API. If you look at the canvas, and it's actually called a canvas on Android and the web canvas, it's draw a line, draw a circle, draw shadows, whatever it may be. Unfortunately, there are small changes throughout. So if you look at things like compositing and how they composite colors and the compositing modes available, things are a little bit different. So a lot of what we had to do to make this replay happen is re-implement some of those compositing modes.
How about iOS?
Well, iOS is a little bit more fun. iOS development ends up being a little more, I don't know if reverse engineering is the right word, but you can't just go in, you can't just read the code. And at this point, there's also layers upon layers of APIs. Every time Apple changes their draw APIs or how you build views, they keep the old stuff around and they build on that to create the newer things. So iOS does have something that looks a lot like Canvas. They call it a CA layer. And that CA layer can receive draw operations. The difference for iOS is that it's actually structured a lot more like a DOM. You don't have one canvas, you have many canvases. And they get drawn to almost like a DOM sort of rectangle. Here's the button, we draw the contents of the button, and then it composites all of those layers together, which lets it do very interesting things, like very smooth animations. It can composite a layer, and then it can just move that layer across the screen without having to redraw it. But we can also capture those same operations.
Any substantial differences between like the iOS capture and replay method or Android, or it's kind of like obviously there's differences, but like conceptually reasonably similar?
Conceptually reasonably similar, and our playback code is at this point identical. So we can take a stream of Android draw events and a stream of iOS draw events, and we've got it down to a point where those will play back the same.
And so what I'm curious is on web, there's kind of like you build your apps with the DOM, you have JavaScript. There's not like a lot of choice in terms of tooling. Obviously, there's a million frameworks, but it sounds like LogRocket. Well, I know LogRocket is agnostic as to to what framework, whether you're using React or Vue, or like where we sit at a layer below where frameworks matter. So it doesn't really affect us on web for the most part. I'm curious on mobile. Obviously on Android and iOS, completely different tool chains, different programming languages, and even on each platform, you have different options. On Android, there's like Dart, Flutter, there's um, React Native for both iOS and Android. So, like, does it matter what toolchain you're using, and if so, like, what have we have to do? What have we had to do in building LogRocket to support all these different toolchains?
Yeah, I will say I don't envy mobile engineers, especially if you're on the hook for supporting a legacy app in both iOS and Android. If someone started rewriting your Objective C in Swift, your Java in Kotlin, now you need to know 4 languages, and someone up high said, "Okay, now we're rewriting this whole thing in React Native, and now you have a fifth." It's kind of like that comic about standards, and now there's another standard. So we support the native code, Objective C, Swift, Java, Kotlin. If you're interacting with native iOS or Android APIs, that all works fine. When it comes to the modern sort of shims where you write something once, and I think the truth there is you write most of it once and then you still end up with a little bit of Swift code and a little bit of Kotlin code for the platform specific pieces. There it gets a little more tricky. So we support React Native. And if you're on the web and you write something in React, then all of your bugs are in JavaScript. That's just not true on mobile. Your bug might be in JavaScript or in Swift or Kotlin. And then currently we don't support Flutter and Xamarin. They all work roughly the same. You have this sort of bridge between the language they're written in, whether it's Dart or C# or JavaScript. So we can still record the native side, but you won't get your Dart issues. You won't get your C# exceptions. And those are things that we're looking at for the future.
Do we do set like screen capture if you have an app in Flutter Dart? Do we do the screen capture but just not have like exceptions or crashes or logs, or even the screen capture would require us to do more in the future to support?
It depends a little bit on how your app is built, but for the most part, we won't capture the screen. They end up using their own draw code. In the case of Flutter, they have a very similar library to what Android uses, but they re-implement a lot of the rendering code themselves.
Got it. And for React Native, does React Native use the same kind of the native rendering on iOS and Android, and that's why we are able to support React Native?
That, and we happen to already have a JavaScript SDK that we could reuse a fair amount of code from. So that was just a pretty easy lift for us. And as you know, LogRocket actually came out of a pivot from a React Native company. So we have some prior experience there.
I'm curious, like, in terms of what you're seeing in the market when you talk to teams that are using LogRocket or not using LogRocket, just general engineering teams who are building mobile apps, does it seem like React Native is, taking over more and more of the market, or is there still a place for true native apps? And how do teams kind of think about that choice?
I think something we see a lot is that very small teams will start with one native app and they'll write it in Swift because the engineer knows Swift. And then they'll be told, okay, now also build an Android one. And maybe they start writing it in Kotlin. And then they decide that the team is too small and we're going to use React Native or Flutter or one of those tool sets. As they get bigger, they go back to writing it in the native code. It's just much nicer at the end of the day to write in all native code if you have the team to support it. So it largely depends on company size and how much of a priority their mobile app is. If it's a sort of second-class citizen and you put it out just because people want it, then it's probably in React Native. If it's a true first-class citizen, it's probably written in a native language.
That's interesting, because I would have thought it's the decision is typically like, okay, we need a mobile app. Oh, let's just use React Native because it will work on iOS and Android. And I know it's not that straightforward, but you could say you get to share 70% of your code. But it sounds like what you've seen is people decide we're going to support iOS or Android first. They build native on that platform, and then when they go to the other platform, then they're like, oh, well, it'll be easier to use React Native for that other platform.
Yeah, and of course it depends on the team you have, what they know, what they're comfortable with. But the truth is, if you're going to build something in React Native, you're also learning the native code bases. It's almost unavoidable. Unless it's really trivial, you will have something on the native side that you need to support separately. And then you're supporting 3-5 languages.
So shifting gears completely here, as I mentioned early on, Pascal, you were the first engineer on the team here, and now lead all of engineering, and it's probably I should probably know this, 35 people or something like that on the engineering team.
Somewhere in the 30s.
So yeah, what has that journey been like? What do you if you could tell yourself from 5 years ago something, what advice would you share?
That's a good question. I think a lot of the advice is just kind of go with it. Embrace the change. It goes from 3 people to 10 people really fast. And then for us, it's also gone from 10 people to more than 100 people really, really quickly. And it's not going to be the same. You start talking about things like culture and how to keep the culture the same. But I think in many ways, you just try to keep the things that are good and you get rid of things that are bad. And some of the good things will come along from new people, and some of the bad things will come along with new people, and you just kind of have to embrace it. So I think I was a lot more change averse 5 years ago. And the other piece is if you're moving from engineering into management, you're not going to code as much, and you just kind of have to accept that. And that takes a little bit of time.
Do you write code nowadays or not much?
Not enough to say I write code.
Yeah.
I've dabbled a little bit in the mobile code just so I know what's going on. But I think the team has done the bulk of the work there for sure. Do you still write code?
Rarely, very rarely. Not if anyone else has anything to say about it. I still hear once in a while I'll hear engineers gleefully talking about old code I wrote and how they recently removed it, and it's a good place to be.
If it's lasted 5 years, it did its job.
That's true. Yeah. So thanks so much for joining us, Pascal. Normally, this is the point of the episode where I ask our guest, do you want to plug your project or something you're working on? But I feel like we've already talked a lot about LogRocket, but perhaps I know we're always hiring engineers. So are you any particular roles you want to highlight that we're hiring for?
We are always hiring engineers, and I'll just plug LogRocket in this spot in case you haven't heard of it. A lot of what we hire are full stack engineers. If you're not afraid of new code, of different code, we are happy to talk to you. If you like infrastructure, SRE, security, we are more than happy to talk to you. So please reach out to myself, to our recruiting team, whoever you can find. It doesn't hurt to have a conversation. And yeah, go use LogRocket.